Hello everyone, this is from Focus Time. Today we are going to discuss about soft computing, a very simple topic that is finding the hyperplane over x and y plane. So let's start from an example one. Take the data points. The first given point is 3, 1, 3 minus 1, 6, 1 and 6 minus 1. So these are the positive data points, and 1, 0, 0, 1, 0 minus 1, minus 1, 0 are the negative data points we are placing on x and y plane. So this is a question. So we are going to use MMC to find hyperplane. The given positive points are 3, 1, 3 minus 1, 6, 1, 6 minus 1, and the negative data points are 1, 0, 0, 1, 0 minus 1, minus 1, 0. So our next step is to plot this points on x and y plane. So I plot the normal points, that is 0, 1, 2, 3, which is on x-axis and y-axis, minus y-axis and minus x-axis. Now using these points you have to plot the points over this x and y plane. Fine. So the first point is 3, 1. This is belongs to x and this belongs to y. So 3 which is on x and 1 which is on y. So we are going to plot here. So as this is a belongs to a positive data points, I am going to mark plus. Fine. Next, the second point is 3 minus 1. 3 minus 1, which is on the y plane. So 3 minus 1. So I am going to place here. Fine. Next point is 6, 1. 6, 1. I am going to place over here. And 6 minus 1. 6 minus 1. So we are going to place here. Fine. So next, negative points. What are the negative points? 1, 0, 0, 1, 0 minus 1, minus 1, 0, which are negative points. So as I've already told, this is x and this is y. So 1 and 0, 1 and 0, which is on the same path. So I'm going to mark here, which is a negative point. Next, 0, 1, 0, 1. So I'm going to mark negative on this point. So next, 0 minus 1, 0 minus 1. So I'm going to mark over here. Next is minus 1, 0, minus 1, 0. So which is on this plane. Fine. So our goal is to find which are the positive and which are the negative points, whether they are going to get separated. We need to separate the positive and the negative points which has been plotted on this x and y plane, right? Going to mark a separating hyperplane which will shows that the positive and the negative points are separated by the separating hyperplane. And this belongs to a linear SVM. So this is a linear SVM. If the points are being separated, like negative and the positive data points are separated with the help of the separating hyperplane, so this we call it as linear SVM. So there is no conversion. If it is non-linear, you need to convert the like non-linear to linear. But here it is already a linear SVM, so it is easy to move to the next step. So this is our first step. After getting a data points, the given data points, you need to plot x and y plane. So this is our first step. Moving to the second step. With the help of the graph, we need to identify the points, super vectors. So what are the exact points that we have to find here? So which is near to the separating hyperplane? The points which are near to the separating hyperplane, that are this, and towards the positive, these 2 points, right? So towards negative I move, this is the point which is closest to this separating hyperplane, and if I move to the right side, I get the same which is on the same path, right, on the same line, which is 3, 1, and this is on 3 minus 1, and this is 1, 0. So these 3 points that I am going to consider for the next step. So these are the 3 points that I am going to consider for the second step. So first I consider this as S1, the first point, that is 1, 0. S2, 3, 1. S3, 3 minus 1. 1, 0, 3, 1, 3 minus 1. So these are the 3 points that I am going to consider. Now, for the super vector, we are going to place a vector. So here there is a condition that 1 0 write it same way on the column wise. I am considering the super vector which is S1 bar, that is a vector. So write down 1 and 0 the same thing. Here which is by default you need to add the bias, that is 1 for all the terms. So this is nothing but a bias for the every super vector, which is very compulsory to write on 1 at the end of the given points. Okay. Next S2 the super vector which is 3 1 and 1 which is bias. Next S3 which is 3 minus 1 and 1. So these are the super vector of S1 S2 and S3. Fine. So now with the help of this we need to construct a formula for the next step, which is nothing but for to perform the dot product rule. So the formula is alpha 1 S1 S1 plus alpha 2 S2 S1 plus alpha 3 S3 S1 which is equals to minus 1. So this is the first equation or start. Next alpha 1 S1 S2 plus alpha 2 S2 S2 plus alpha 3 S3 S2 which is equals to 1. Alpha 1 S1 S3 plus alpha 2 S2 S3 plus alpha 3 S3 S3 which is equals to 1. So why am I writing 3 equation? Why am I writing 3 equation? Because we have got 1, 2 and 3 super vectors. So I am writing, this is a basic formula that you need to remember. It's an equation. Okay, so the formula that you're considering, the 3 sub formulas, that because of you have got the super vector S1 S2 and S3 S1 S2 and S3 S1 S2 and S3 S1 S2 S3. So this is the way you have to perform. If it is 4, the same thing you have to write down. So minus 1 1 1 1, that's it. So the equations change off. So here you will get S1 S1 S2 S1 S3 S1 S4 S1. Like this you have to construct the formula. So this is a basic formula that you need to remember. Now we are performing dot product to multiply two vector. Now considering the first formula, which is 1 S1 S1 plus alpha 2 S2 S1 plus alpha 3 S3 S1 which is equals to minus 1. Alpha 1, keep it as it is. S1, what is the value of S1? 1 0 1, right? So the S1, what is the formula of S1? What we got? S1 is 1 0 1, S2 is 3 1 1, S3 is 3 minus 1 1, right? So the same thing you have to substitute here. 1 0 1 S1 1 0 1 alpha 2 S2, S2 value is 3 1 1, 1 is 1 0 1 alpha 3 3 minus 1 1, S1 is 1 0 1 which is equals to minus 1. Fine. Now you need to perform multiplication. Alpha 1, 1 into 1 is 1, 0 into 0 0, 1 into 1 is 1 plus alpha 2, 3 ones are 3, 1 0 is 0, 1 into 1 is 1 plus alpha 3, 3 into 1 is 3, minus 1 into 0 is 0, 1 into 1 is 1 equals to minus 1. So for further simplification, 2 alpha 1 plus 4 alpha 2, 4 alpha 2 plus 4 alpha 3 which is equals to minus 1. So this I am considering it as equation 1. So moving to the second equation, S1 S plus alpha 2 S2 S2 plus alpha 3 S3 S2 super vector equals to 1. So as we already know, alpha 1, keep it as it is. S1 is 1 0 1, S2 is 3 1 1, alpha 2, keep it as it is. S2 3 1 1, 3 1 1, alpha 3, keep it as it is. S3 is 3 minus 1 1 and S2 is 3 1 1 which is equals to 1. Fine. So these are the Just we are substituting the values of the S2, S1, S2, S2, S3, S2. Okay. So this is the term. Next, simplifying. 4 alpha 1 plus 11 alpha 2 plus 9 alpha 3 is equals to 1. So how did you get this? 3 into 1 is 4 plus 0 into 1 is 1, like 0. 1 into 1 is 1. So 3 plus 0 plus 1, which is equals to 4. Next, 3 3 is a 9 plus 1 plus 1. 9, 10, 11. So 11 alpha 2. Next, 3 minus 1 plus 1. 3 into 3 is 9 minus 1 plus 1. So 9 alpha 3, which is equals to 1. So these are the simplified terms of this step. Fine. So this is equation 2. So considering the third sub equation, that is alpha 1 S1 S3 plus alpha 2 S2 S3 plus alpha 3 S3 S3, which is equals to 1. Right. So same thing you are going to do here. So this is a third sub equation for the same thing that I have directly written out. So S1 is 3 1 0 1, S3 is 3 minus 1 1, and S2 is 3 1 1, S3. So this is the third equation, alpha 1. S1 is 1 0 1, and S3 is 3 minus 1 1. So you will get 3 0 plus 1. Next, S2 is 3 1 1, S3 is 3 minus 1 1. So we'll get 3 3 is a 9 minus 1 plus 1. Next, S3 is 3 minus 1 1, S3 is 3 minus 1. So you will get 9 plus 1 plus 1. So next, the simplified form is 4 alpha 1 plus 9 alpha 2 plus 11 alpha 3 is equals to 1. So this is considering as third equation. Now by considering the equation 1, 2 and 3, so like write it down. Now by considering the 3 equation, which is 2 alpha 1 plus 4 alpha 2 plus 4 alpha 3, which is equals to minus 1, which I given as equation 1, equation 2 and equation 3. Now we are going to perform considering the only 1 and 2 equation. So in order to get alpha 1 or alpha 2 or alpha 3. So how? So let me consider the first equation, alpha 2 plus 4 alpha 3 equals to minus 1. 4 alpha 1 plus 11 alpha 2 plus 9 alpha 3, which is equals to 1. So I need to cancel the terms. So I take the common thing. I consider the alpha 1. I make this two terms as common. So in order to make it common, I multiply this by 4. No, by 2. Because 2 into 2 is 4. So this by 1. So what happens here is 4 alpha 1, 8 alpha 2, 4 2s are 8 plus 4 2s are 8 alpha 3 equals to minus 1. Next, 4 alpha 1 plus 11 alpha 2 plus 9 alpha 3, which is equals to 1. Now change the sign. So it is very compulsory. It is compulsory to changing the sign of the each terms. So minus 4 plus 4 get cancelled. Next, 8 minus 11 minus 3 minus 3 alpha 2 minus alpha 3, which is 1, alpha 3 equals to, this is minus 1 into 2, right? So you'll get 2 minus 2, 1, which is nothing but minus 3. So I consider this as a fourth equation. So any doubt in this? So this made a mistake. So this is minus 1 into 2 is 2. So you will get your minus 2. So minus 2 minus 1, which becomes minus 3. Fine. Now by considering equation 2 and 3. So which are the equation 2 and 3? 4 alpha 1 plus 11 alpha 2 plus 9 alpha 3 equals to 1. And the equation 3 is 4 alpha 1 plus 9 alpha 2 plus 11 alpha 3, which is equals to 1. Again, I need to cancel the terms. We know these are the common thing, 4 and 4, right? So just see like signs. So you need to change the sign, cancel it directly. So 4 alpha 1 get cancelled, and the remaining terms that you will get is 2 alpha 2 minus 2 alpha 3, which is equals to 0. So we know these are the common thing that will be divided by the 2. So you can directly write it out. Alpha 2 minus alpha 3 equals to 0, which is equation 5. Fine. So now I am substituting the equation 4 and equation 5. Equation 4 was minus 3 alpha 2 minus alpha 3 equals to minus 3. And equation 5 is alpha 2 minus alpha 3 is equals to 0. So why am I considering equation 4 and 5? Because I need to cancel the terms and I want to get either alpha 3 as a value or alpha 2 as a value, the final value. So for that I am considering any of the equation you can consider, or by this time I've only got the 4 and 5, right? So I'm considering only the 4 and 5, and I'm like cancelling the terms in order to get the value. So here what happens after changing the sign? This is plus, I'm changing to minus, and this is minus. So this terms get cancelled, and I'll get 4 alpha 2, which is equals to minus 3, and alpha 2 is nothing but minus 3 divided by minus 4. Minus minus get cancelled. 3 by 4, which is nothing but 0.75. So alpha 2 value is 0.75. To get the value of the alpha 2, so I have taken equation 4 and 5. Do you have any doubt till here? No. Next, now considering equation 5, that is alpha 2 minus alpha 3, which is equals to 0. Fine. So alpha 2 value is 3 by 4. 3 by 4 minus alpha 3, which is equals to 0. So keep it on the left side. Alpha 3, which is equals to 3 by 4. Again we get 0.75 as a value for alpha 3. So alpha 3 value is nothing but 0.75. Now from equation 1, equation 1 says 2 alpha 1 plus 4 alpha 2 plus 4 alpha 3, right? So which is equals to minus 1. Now keep it as it is, 2 alpha 1, and put all this towards the right side, because we already got the value of alpha 2 and alpha 3. So I'm putting it over the right side, over the RHS. So minus 1 minus 4 alpha 2 minus 4 alpha 3. So 2 alpha 1, keep it as it is, minus 1 minus 4 3 by 4 minus 4 3 by 4. So now we can easily cancel these terms, right? So 2 alpha 1 equals to minus 1 minus 3 minus 3. So alpha 1, which is nothing but minus 7 by 2. How? 3 3 6 7. 7 by 2, which is equals to minus 3.5. So the value of alpha 1 is nothing but minus 3.5. So after finding the value of alpha 1, alpha 2 and alpha 3, so we need to know the optimal hyperplane, the formula given for the optimal hyperplane, which is given by W vector sum of B alpha and Si, the super vector. So how? We know the first alpha 1 S1 plus alpha 2 S2 plus alpha 3 S3. This is the expansion of this formula, which is nothing but the sum of alpha 1, alpha and Si, right? So alpha 1 S1 plus alpha 2 S2 plus alpha 3 S3. Fine. So now we know the value of alpha 1 is minus 3.5, S1 is 101, right? Next, alpha 2 is 0.75 and S2 is 311, and alpha 3 is 0.75 and S3 is 3 minus 1 1. So after performing the multiplication, minus 3.5 into 1 is minus 3.5, 0 minus 3.5 plus 0.75 into 3, which is nothing but 2.25, 0.75, 0.75 plus same thing, 2.25 minus 0.75, 0.75. Now minus 3.5 plus 2.25 plus 2.25, which is nothing but 1, which is nothing but 0, and minus 3.5 plus 0.75 plus 0.75, which is nothing but minus 2. So here you need to consider is, this is the offset, and this belongs to x, this belongs to y, and this is the offset. In the initial step you have taken it as 1, if you have remembered, which is positive, and this you have got it is negative. So you have to neglect the negative sign. So 2 is a offset for the given data points. Fine. As we know the equation of the hyperplane equation, which says y is equals to wx plus b. So we know the w we have got, which is nothing but 1 and 0, right? So w, which is 1 and 0, and b is nothing but minus 2, neglect negative sign, so you have to write 2. So b is equals to 2. Now the final step is you need to plot it on the graph. graph, right? So I considered 0, 1, 2, 3 on x, 1, 2, 1, 2, minus, and this is minus 1, minus 2. As we know, it is 2, right? So mark 2 over x axis and on y axis. So you need to mark. This is the final step of getting an hyperplane, which is a linear on a linear SVM. Fine. So this is the final step for the given data points in order to find the hyperplane using MMC. Thank you.